Assalamu alaikum viewers, please like, share and subscribe this channel. Links of PDF files used in this video are given in description. So today's lecture is about secondary pollutants that are present in photochemical smog, and this is the part 8 of a lecture series about atmosphere and pollution. So in the previous lecture we have discussed in a brief way about photochemical smoke, how it is produced and what are its effects. So in that lecture we have learned that actually there are three types of products that are found in photochemical smoke. So number one is the ozone formation. This is also called as ground cell level ozone or tropospheric ozone. Second pollutant or secondary product which is formed during photochemical smoke is called as peroxyacetyl nitrate formation, or simply called as PAN formation. And third is the formation of aerosol particles. So in this lecture we will see how these products or secondary pollutants are generated during the occurring of photochemical smoke. Actually, Professor Ari Haagen-Smit, a perfumery chemist at the California Institute of Technology, was the first to show that placing automobile emissions containing nitrogen oxides such as nitrogen oxide and nitrogen dioxide and unburned hydrocarbons in the presence of sunlight would produce ozone and eye irritants such as formaldehyde. Later, Professor Blacet, chemistry professor at the University of California, Los Angeles, was the first to point out that NO2 photolysis was responsible for the production of oxygen atoms in the troposphere. This led to the realization that following chemistry was responsible for both the production and loss of ozone in the troposphere. So let's see these reactions. So NO2, which is coming from the traffic emissions or automobile emissions in the presence of sunlight, having the UV radiations of this range, produce nitrogen oxide and oxygen. Then this oxygen atom in the presence of atmospheric oxygen and in the presence of a third body particle such as nitrogen, oxygen or argon produces this ozone. And in the next reaction, this ozone is then consumed by the NO to produce NO2 and O2. Now this NO2 can initiate the cycle further, and in this way the again the cycle starts and different products are formed. It is to note that first three reactions led to the situation where the ozone formation is dependent on the concentration ratio of NO2 and NO and the intensity of sunlight. The observation of elevated levels of ozone in the photochemical smoke led to the conclusion that apart from these reactions, certain other radicals were also important in this chemistry. These additional radical species were tied to the organics that were necessary part of smoke formation. A number of researchers concluded that hydroxyl radical, hydroperoxyl radical, and the associated organic peroxy radicals were the key to the photochemical chain reaction that allow for the conversion of NO into NO2. Thus, increased NO2 and decreased NO concentration result in the enhanced ozone formation due to the reactions number 1 and reaction number 2. The key initiation step leading to the formation of the hydroxide is the photolysis of ozone, yielding an electrically excited oxygen atom. So if we see here in this reaction that ozone in the presence of sunlight decomposes into oxygen and this oxygen free atom. This oxygen free atom then further reacts with water vapor and in the air to form the hydroxide species. So once hydroxide formed, and it can react further with carbon monoxide or hydrocarbons to create reactive peroxy radicals, and in this way again setting up a chain reaction for the production of ozone. So hydroperoxy radical produced here react with nitric oxide to produce NO2 and hydroxide. This NO2 then again in the presence of sunlight produce NO and O. So we can say here that we have resulted into this reaction again, and as a result of NO2 production and in the presence of sunlight, again the ozone is formed by the reaction number 2. So hydroxide can react with organic moiety or simple hydrocarbons such as ethane rather than to react with carbon monoxide to produce water and ethane radical. This then radical further react with oxygen to form ethoxy radical. This ethoxy radical then in the presence of nitrogen oxide produce nitrogen dioxide, and this nitrogen dioxide again then further in the presence of sunlight produces atomic oxygen, which in the presence of oxygen produce ozone. Or this ethoxy radical further reacts with oxygen to form hydroperoxy radical. Now this hydroperoxy radical in the presence of sunlight produces NO2. This NO2 in the presence of sunlight produces nitrogen oxide and oxygen. So again this reaction starts here and again the ozone is produced. So we can summarize that during the ozone formation, this is the main reaction, but in this reaction here in the second step ozone is formed, but in the next step this ozone is consumed. So the level of tropospheric ozone during smoke formation is very much high. It means other species are involved. Those other species include hydroxide radical, hydrogen peroxide radical. So how this OH is produced, it has been explained in these reactions, and how HO2 is produced is explained in these reactions. Then HO2 further produces NO2, and this NO2 then initiate the cycle again. Or the hydroxide radical which is produced here, rather than to react with carbon monoxide, it react with organic moieties to produce NO2. This NO2 then breaks down like this, and it further starts this reaction to produce ozone. Or the ethoxy radical which is produced here, it can react with oxygen to form hydroperoxy radical. This hydroperoxy radical then do this reaction and then it cause this reaction, and in this way again ozone is formed. So in this way a catalytic cycle starts and smoke is formed, and during this smoke the ozone formation at the tropospheric level increases. So the ground level ozone is the perfect indicator for the identification of photochemical smoke. Now how this cycle terminates? This cycle may terminate if the NO present in the atmosphere is not available, or the reaction of OH with nitrogen dioxide to form nitric acid is one of the termination step, and this step we will explain in the next part of the lecture. So next we see how the secondary product pan or peroxyacetyl nitrate is formed during the photochemical smoke. So here this is the acetaldehyde, and it is emitted directly from the automobile exhaust or from the secondary reactions. This acetaldehyde can react with hydroxide, and the abstraction of acetaldehydic hydrogen led to the formation of acetyl radical. This acetyl radical in the presence of oxygen form peroxyacetyl radical. The peroxyacetyl radical then can react with nitric oxide to form nitrogen dioxide. Now this product form then further decomposes into methyl radical plus carbon dioxide. Methyl radical in the presence of oxygen then produce this radical, and this radical further reacts with nitrogen oxide to form NO2 and HO2. So this set of smoke chemistry radicals led to the production of ultimately an acetaldehyde compound along with the hydrogen peroxy radical. These in turn react with nitric oxide to form hydroxide. The peroxyacetyl radical can add up NO2 directly, and it can form the peroxyacetyl nitrate product. The formation of peroxyacetyl nitrate was discovered by agriculture researchers who had identified a new type of plant damage in the Los Angeles. The damage includes leaf bronzing of a number of plant species. This bronzing was did not resembling with the damage due to ozone or sulfur dioxide, so a new type of compound was discovered, and the culprit behind this bronzing of plant leaves was identified because of the presence of peroxyacetyl nitrate in the air. This peroxyacetyl nitrate here drawn is a single compound, however, it has a species of compounds, and these are known as PANs. The PANs are eye irritants and they are not water soluble. They have low photolysis rates and are very slow to react with hydroxyl radical and are thermally decomposed into their precursors such as peroxyacetyl radicals and nitrogen dioxides. Therefore, these compounds are very important means of transporting nitrogen dioxide from urban areas onto regional or global scale. Besides the formation of oxidants formed from the chemical reactions as described in the above section, three other sets of reactions involve chain termination steps. The first chain termination step is the reaction of hydroxyl radical with nitrogen dioxide to form the nitric acid or HNO3. The nitric acid formed in this way removes both chain carrying hydroxide radical and NO2, and however the nitric acid is very soluble in water and is a strong acid, and it thus contributes to another aspect of smog, and that is production of acidic species. So these acidic species in the presence of ammonia, it will generate ammonium nitrate, and this ammonium nitrate is formed as a secondary aerosol particle. The second reaction involving the chain termination step is the reaction of HO2 with itself. So this produces the final product, which is called as H2O2 or hydrogen peroxide. The hydrogen peroxide then reacts with the presence of sulfur dioxide, which is again emitted from the combustion of fossil fuels to form a more stronger acid, which is called as H2SO4 or sulfuric acid. Now this sulfuric acid, after reacting with ammonia, then produce ammonium sulfate and ammonium bisulfate. These are again the lead to the formation of aerosol particles. Apart from ammonium nitrate, ammonium sulfate, and ammonium bisulfate, various large organic compounds emitted into the air can be oxidized to form secondary organic aerosols. Indeed, natural monoterpene hydrocarbons, which are emitted from the rubber making trees, can react with energy related pollutants and secondary ozone to form a variety of smog aerosols. Similarly, the carbonaceous soot can also be emitted directly from the automobiles and diesel engines. This soot contain oily organic coatings and associated with polyaromatic hydrocarbons. Then there is the emission of road dust. This is also contributing in the formation of aerosols, and this road dust is produced from tire erosion, road work, and traffic. Next, sea salt spray forms the aerosol particles, and these sea salt aerosols from surf and windy spray can also add to the aerosol burden near ocean shores. Wind blown dust is another source of aerosol formation, and it is mostly present in desert regions, and it travels a very long distances, and it can transport up to the Atlantic and Pacific Oceans. These wind blown dusts are adding to the background in many cities like Beijing, China, and contribute to the brown clouds in Asia. All of the aerosol species can play important role in radiative balance of the atmosphere on urban, regional and global scales. So in this way, these equations describe how these three products are formed, and there are various types of chemical reactions that are occurring in the troposphere that produce the photochemical smoke, and then this photochemical smoke actually contains these three important formation species. So this was all about today's lecture. I hope you have well understood this lecture, but if you have still confusion in your mind, you can ask your question in the comment section of this video. I will respond to your queries as soon as possible. Okay, thank you. Allah Hafiz.